This release was updated on March 17, 2021, to correctly identify the ERS instrument as being aboard NASA's Aqua, not Aura, satellite. Earth's global average surface temperature in 2020 tied with 2016 as the warmest year on record, according to an analysis by NASA. Continuing the planet's long-term warming trend, the year's globally average temperature was 1.84 degrees Fahrenheit, 1.02 degrees Celsius, warmer than the baseline 1951 to 1980 mean. According to scientists at NASA's Goddard Institute for Space Studies, GISS, in New York, 2020 edged out 2016 by a very small amount, within the margin of error of the analysis, making the years effectively tied for the warmest year on record. The last 7 years have been the warmest 7 years on record, typifying the ongoing and dramatic warming trend, said GISS Director Gavin Schmidt. Whether one year is a record or not is not really that important. The important things are long-term trends. With these trends, and as the human impact on the climate increases, we have to expect that records will continue to be broken. The largest source of year-to-year variability in global temperatures typically comes from the El Nino-Southern Oscillation, ENSO, a naturally occurring cycle of heat exchange between the ocean and atmosphere. While the year has ended in a negative, cool, phase of ENSO, it started in a slightly positive, warm, phase, which marginally increased the average overall temperature. The cooling influence from the negative phase is expected to have a larger influence on 2021 than 2020. The previous record warm year, 2016, received a significant boost from a strong El Niño. The lack of a similar assist from El Niño this year is evidence that the background climate continues to warm due to greenhouse gases, Schmidt said. The 2020 GISS values represent surface temperatures averaged over both the whole globe and the entire year. Local weather plays a role in regional temperature variations, so not every region on Earth experiences similar amounts of warming even in a record year. According to NOAA, parts of the continental United States experienced record-high temperatures in 2020, while others did not. A warming, changing world tracking global temperature trends provides a critical indicator of the impact of human activities, specifically greenhouse gas emissions, on our planet. Earth's average temperature has risen more than 2 degrees Fahrenheit, 1.2 degrees Celsius, since the late 19th century. Rising temperatures are causing phenomena such as loss of sea ice and ice sheet mass, sea level rise, longer and more intense heat waves, and shifts in plant and animal habitats. Understanding such long-term climate trends is essential for the safety and quality of human life, allowing humans to adapt to the changing environment in ways such as planting different crops, managing our water resources and preparing for extreme weather events. Ranking the records a separate, independent analysis by the National Oceanic and Atmospheric Administration, NOAA, concluded that 2020 was the second warmest year in their record, behind 2016. NOAA scientists use much of the same raw temperature data in their analysis, but have a different baseline period, 1901 to 2000, and methodology. Unlike NASA, NOAA also does not infer temperatures in polar regions lacking observations, which accounts for much of the difference between NASA and NOAA records. Like all scientific data, these temperature findings contain a small amount of uncertainty, in this case, mainly due to changes in weather station locations and temperature measurement methods over time. The GISS temperature analysis, GISS-TEMP, is accurate to within 0.1 degrees Fahrenheit with a 95% confidence level for the most recent period. Beyond a global, annual average, while the long-term trend of warming continues, a variety of events and factors contribute to any particular year's average temperature. Two separate events change the amount of sunlight reaching the Earth's surface. The Australian bushfires during the first half of the year burned 46 million acres of land, releasing smoke and other particles more than 18 miles high in the atmosphere, blocking sunlight and likely cooling the atmosphere slightly. In contrast, global shutdowns related to the ongoing coronavirus, COVID-19, pandemic reduced particulate air pollution in many areas, allowing more sunlight to reach the surface and producing a small but potentially significant warming effect. These shutdowns also appear to have reduced the amount of carbon dioxide, CO2, emissions last year, but overall CO2 concentrations continue to increase, And since warming is related to cumulative emissions, the overall amount of avoided warming will be minimal.